Welcome to the first lesson in Session 5, Adding and Subtracting Polynomials. We start by defining polynomials. And a polynomial is a general term just to indicate that we have many terms. The prefix poly, meaning many, and the suffix nomials, meaning terms. So it's just a general term indicating that we have many terms in our algebraic expression. Two ways to classify polynomials is first by the number of terms, and second by the degree. And by degree, what we're referring to is the largest exponent. We're going to start by classifying polynomials by the number of terms that the expression contains. Now remember, a plus and a minus sign is what separates one term from the next. So if you have a single term, it's referred to as a monomial. For example, 3x to the second is a single term, that's a monomial. If there are two terms, we call it a binomial, negative 4y to the third plus 1. So there's two terms connected with a plus sign, so that's a binomial. And if there are three terms, it's referred to as a trinomial. So an example of a trinomial is a to the third plus 2b minus 3. A to the third being a term, 2b being a term, and negative 3 being a term. So three terms connected is considered a trinomial. Anything larger than three terms is just called a polynomial with n terms. So if there's four terms, we would call it a polynomial with 4 terms or a polynomial with 5 terms. But no special titles after 3 terms. As we move on, we're going to classify polynomials by degree. And when we refer to the degree of a polynomial, we're referring to its largest exponent. So if the largest exponent is 1, it's said to be a linear polynomial. For example, 2x plus 1, the largest variable exponent is 1, 2x to the first. So the x to the first is the largest variable exponent. It equals 1, so that's a linear polynomial. Next, we have a quadratic polynomial if the largest variable exponent equals 2. In our next example, we have 2x to the second equals 2. So as the degree increases by 1, so does the classification of the polynomial. So we go from a linear to a quadratic. And the third one we have is a cubic expression. So a cubic polynomial has the largest variable exponent equal to 3. So 2x to the third plus 3 is considered a cubic expression. So notice it doesn't matter how many terms we have or what the coefficients or what those terms are. Classifying by degree is simply paying attention to the largest variable exponent in the polynomial. Anything larger than a 3 is just referred to as an nth degree polynomial, so a 4th degree polynomial or a 5th degree polynomial, and so on and so forth. Now when it comes to combining like terms, terms can only be added or subtracted if they contain the exact same variables and the exact same exponents. So if two terms have the exact same variables and the same exponents, we can combine them by adding or subtracting their coefficients. Now we're going to add polynomials. When adding polynomials, all we're going to do is add or subtract the coefficient of the like terms. So the variables and exponents don't change. All we do is combine the coefficient of like terms. So our first example, we're going to add two quadratic trinomials, 7x to the second plus 8x minus 5. We're going to add that to 9x to the second minus 9x plus 3. Now notice both of those polynomials have 3 terms, and the largest variable exponent is 2. So that makes them quadratic trinomials. So we combine our like terms, so 7x to the second and 9x to the second get combined to give us 16x to the second. 8x minus 9x combined to give us negative x, and negative 5 plus 3 combined to give us negative 2. And we can't simplify that expression any further, so we accept that as our answer. So for our next problem, again, we have quadratic trinomials. So we combine x to the second and negative 3x to the second, giving us negative 2x to the second. 9x and negative 9x add to 0 and will cancel out. And negative 8 and a positive 11 combine to give us a positive 3. So adding these two polynomials gives us negative 2x squared plus 3. And when subtracting polynomials, we first have to distribute the negative through the entire second polynomials prior to combining our like terms. So we have 7x to the second plus 8x minus 5. Now in this case, we're going to subtract 9x to the second minus 9x plus 3. So my first polynomial stays exactly as it is. My second polynomial has to get distributed by the negative sign. So distributing the negative to the second polynomial will look like this. We'll have 7x to the second plus 8x minus 5, and that will become a negative 9x to the second, a positive 9x, and a negative 3. Now when we combine like terms, 7x to the second minus 9x to the second give us negative 2x to the second. 8x and 9x combine to give us 17x, and negative 5 and negative 3 combine to give us negative 8. Again, in the second example, the same thing. The first three terms stay exactly as they are, but I have to distribute the negative into the second trinomial. So we're going to have 8x to the second plus 9x minus 8, positive 3x to the second, a positive 9x, and a negative 11. Now when I combine my like terms, x to the second and 3x to the second give me 4x to the second. 9x and 9x combine to give us 18x, and negative 8 and negative 11 combine to give us negative 19. So 4x squared plus 18x minus 19 is our answer. That wraps up everything for this lesson. Good luck on the quiz, and email us if you have any questions. Good luck.